In this video, we are going to see about kinematics and dynamics of machines, which is one of the major subject and course in BTech Mechanical Engineering. And in kinematics and dynamics of machines, especially we are going to see the mechanisms and kinematics as a first part. So here we are going to see the general definition of the mechanisms and machines. What is a mechanism? A mechanism is a system of interconnected links designed to transmit the motion. As you can able to know, its mechanism having different kind of links which is interconnected with each other, which is applicable in real-time machines also. So mechanism plays a crucial role for making an overall machine as well. So generally it is given here, mechanism is a system of interconnected links and designed to transmit the motion. And then we will move on to the machine. What is a machine? A machine is a mechanism that also transmit force to perform work. See, machine is a having a number of mechanisms. Mechanism is a part of a machine. So here it is given perfectly. So from this you can able to know what is a machine. Machine is a mechanism that transmit force to perform work. So mechanisms are the building blocks of machines, as I already said about it. So these are the basic things from mechanisms and machines. So this kind of questions will ask in interview. So just learn about it, and then we will go on to the terminology. So as you learn about the terminology here, link a rigid body that connects to other link via joints. So generally you know what is a link. It's a rod-like structure which is connected to joints to joints. So this makes a crucial role for making a whole structure in mechanism or the kinematic chain. So next we are going to see the kinematic pair. Kinematic pair, a joint that allows relative motion between two links. There is a kinematic pair. You know the surface contact and the higher surface contact as a lower pair and the higher point or line contact as a higher pair, which is also comes under the kinematic pair. So if you talk about the revolute pairs, in revolute pairs, for example, you take any kind of surface contact. For example, the spur gear. While rotating the spur gear, the gear which is in contact with the surface, so that surface makes a lower pair. That is said to be here is in this condition. As examples are given here, revolute and prismatic. And the higher pairs is a point or line contact. For example, if you ride a bike, the tire is having a contact at a point. So this makes a crucial role. Generally, we are assuming a circular object will makes a point, but actually the tire makes some surface having some surface contact with the road. So we don't want to go it deeply. And then if you talk about the cam and follower, there will be a point contact which makes a higher pass. This plays a crucial role in kinematic pair as well. So in MCQs questions they will ask this kind of higher pair and lower pair related questions as well. So this is one of the important topic in terminology. And then we will go on to the kinematic chain. In kinematic chain is a series of links that are connected by pairs forming a closed loop. Chain is a chain like structure which makes a overall structure. And then inversion is nothing but is a fixing of different links in the kinematic chain to obtain different mechanisms. We will see in this upcoming video. So changing the fixed link in the kinetic chain to obtain different mechanism. By fixing different kind of links plays a crucial role. We have a number of joints, crank, rocker, coupler and fixed joint. So by fixing all those things we will get a resultant different output. So we will focus on this in upcoming video. This is a basic terminology in the kinematics. Link, kinematic pair and kinematic chain and inversion. These four are the basic terminologies that you should know about the kinematics. Link is nothing but it's a rigid body that connects other two joints. As you know, if you have any links, this connect. Kinematic pair, as I already showed, the lower pair and higher pair. And the kinematic chain is a series of links. The overall structure is said to be kinematic chain. Inversion is fixing of any kind of link, any link in the force structure. So next we will move on to the planar mechanism and kinematic diagram. Planar mechanism is all motion occurs in a single plane. you can able to understand here all the motions occurs in a single plane itself. So, and then if you talk about the kinematic diagram, a simplified schematic showing only links, joints and ignoring dimension and shape. Kinematic diagram, as I already told about it, it has links and the joints where the links are getting connected and ignoring dimension and shapes. We are not focusing on the dimension and shape of the links, what is here in the kinematic diagram. So this makes a crucial role in planar mechanism and in the kinematic diagram. This is one of the important two basic fundamentals in the kinematics. And then if we talk about the mobility and Grubler's equation, mobility is also known as the degree of freedom. Degree of freedom is ability of a material that move independently without any constraints. That is degree of freedom. So here mobility is said denoted as m, and that Grubler's equation for mechanisms with only lower pairs. As you know, the number of degrees of freedom is a mechanism. DOF, as you know already about this, if you are familiar with the kinematics. And then Grubler's equation is responsible for the mobility, the degree of freedom. This m is also said to be written to be or denoted as DOF. DOF is degree of freedom. Degree of freedom is the ability of a material that move in any kind of direction without any constraint. So here n is a number of links and j is a number of joints. From this you will solve different kind of numerical problems in the upcoming videos. But here in this video we are focusing on only in theory. So we have just learned about the mobility and Grubler's equation. As you know about the degree of freedom, but if you are the first time just knowing about the mobility, then learn it. Mobility is also known as a degree of freedom. And then we will go on to the coincident joints. Coincident joints is a point where multiple links meet at the same location. As you know, the multiple joints which on the line itself, there will be many joints like in same parallel way. So if you see in any kind of a front view, that you can't be able to see the other joints in the same parallel view. So that joint is also known as a coincident joints, and important in velocity and acceleration analysis, especially when analyzing instantaneous centers. So in coincident joints, while we are drawing this kind of acceleration and velocity analysis, this plays a crucial role over there. So be careful while focusing and studying about the coincident joints. Coincident joints, as I already told, points where multiple links meet at the same location. This is a coincident joints. For example, n number of links which is coming from different direction which has same joint at the single location. It is said to be a coincident joints. And then Grashoff's law. In Grashoff's law, as you know already, it determines the motion feasibility in the 4-bar linkage. According to the Grashoff's law, shortest plus longest is less than or equal to other two linkages. The length of the shortest and longest link is less than or equal to the other two summation of linkages. There is a Grashoff's law. As you can able to see here, the formula S plus L is less than or equal to P plus Q. S is the shortest link, L is the longest link, P plus comma Q is the other two links. If the condition is satisfied, at least one link can make a full rotation, which makes a crucial role in Grubler's law. In Grashoff's law. Here you can able to see the Grashoff's law. Here one LSPQ. This is the shortest. S is denoted as S shortest, L is the longest. So if you are adding these two length, then it should be less than or equal to by adding the P plus Q. So this is a basic fundamental Grashoff's law. This may be asked in the technical questions in mechanical engineers. And then the types of kinematic chain we are going to see over here. The types of kinematic chain. This is the whole structure is a kinematic chain which is connected with joints. This part is joints. Thus you can able to see over here. This point is joint. This is a link. This overall structure is kinematic chain. So this has three types: 4-bar chain, single slider crank chain, and then double slider crank chain. These three plays a crucial role. But in this video we are mainly focused on 4-bar chain. So in the 4-bar mechanism, there will be 4 links. As you know already. Here this is a 4 links. In 4 links, it has 4 W pairs also, and it has inversions, 3 inversions. In the 3 inversions, you know, crank rocker, one link rotates fully, other oscillates. This is said to be a crank rocker. Crank rocker is occurs when, here it is given that link adjacent to the shortest is fixed. Link adjacent to the shortest means this is shortest. Adjacent to the shortest means either this third one or this first one. If you fix if we fix this one, this will make a full rotation. So this yellow color you can able to see, this makes a full rotation, this green color makes oscillation. So which the link makes a full rotation is crank, which the link makes oscillation is rocker. So here one full rotation will be there. If you fix this one, if it rotate, this yellow color will rotate fully 360 degree, whereas this green color rotates oscillatory motion. So whatever it rotates fully is crank, and whatever which rotates oscillatory motion is said to be a rocker. So this is said to be a crank rocker mechanism when we fixing the link which is adjacent to the shortest. So if you fixing the third one or the first one, this said to be a crank rocker mechanism that is given over here. And then link opposite to the shortest is fixed. Link opposite to the shortest is, this is shortest, second one is shortest, opposite to the shortest means this fourth one. If you fix this fourth one, if you fix this fourth one, this will make oscillatory motion for the first one and the third one. This will make oscillatory motion for the first one and the third one. So as I already told, what are the things which makes oscillation is rocker, what are things is full rotation is crank. So here there will be motion of second, third and first over here. So as you already see, the link opposite to the shortest is fixed in this case. Here it is said to be a double rocker, because if we fix opposite to the shortest link, this fourth one green color, there will be a oscillatory motion for the third one and the first one. So if any oscillatory motion is coming into picture, that is said to be rocker. So here two oscillatory motion. Here the second one, you might think there will be a full rotation, but there is no full rotation, there is no oscillatory motion, there will be a parallel movement will be there. So here will be, there is a oscillatory motion. So this two makes a crucial role. So we will say this as double rocker mechanism when we are fixing opposite link of the shortest link. So the next one is shortest link is fixed. What will happen if the shortest link is fixed? See, if you fix the shortest link over here, you can able to see, as you can able to understand, there will be a movement of this two linkages, third and first, easily it will move, but there is a double crank rotation. If you make this one, there will be a full rotation of this third one, it will makes fully rotate. And then this one the link one is also makes a full rotation, because the shortest is fixed, there will be a movement like this. This third one will move from here to here, and this first one will move from here to here. There will be a rotation, there will be a clockwise rotation, as you can able to see. So this third one will also makes a full rotation, and the first one will also make a full rotation. So as I already told, if anyone makes the full rotation, it is to be crank. So here the two linkage third and first makes a full rotation, so it is said to be a double crank mechanism. So these kind of things is one of the important thing while we are going for a technical interview, technical questions, technical type of entrance exams. So this is one of the basic concept in 4-bar mechanism. I hope this video is useful for you. In upcoming video we will solve, and we are going to see about the inversion, and we will solve some numerical problems as well. Thank you.